Hello student, good morning. In connection with our previous lecture of network theorem, the second one is the Theorem theorem, in which we have studied the statement of the network theorem and the steps. What are the steps and what are the procedure to solve the network equation. So let's go one by one. Now first of all, Thevenin theorem statement is there, in which the whole the whole about the Thevenin theorem. The statement Thevenin theorem statement says that any linear active network, mind it again applicable for the linear active network consisting of a independent or a dependent voltage and the current source, and the network element can be replaced by the equivalent circuit having a voltage source in a series with a resistance, that voltage being the open circuited voltage across the open circuited load terminals, and the resistance being the internal resistance of the source. See, the statement of the Thevenin theorem, whatever the statement is said, let's go one by one. In other words, if we explain the Thevenin theorem, the current flowing through the resistor connect across any two terminals of the network by the equivalent circuit having a voltage of ETH, or in some book it denoted by the VTH, in the series with the resistance RTH. RTH means Thevenin resistance, where ETH is the open circuit voltage. In some book you have find out this VTH, VOC, in the open circuit voltage between the required two terminal called the Thevenin voltage, and RTH is the equivalent resistance of the network and seems from the two terminal with all sources replaced by their internal resistance called Thevenin resistance. So next slides I am going to teach you I'm giving you the pictorial representation of the Thevenin theorem, which is more easier to learn for you. Let's go for the next slide. Yeah, see, these are the four figure. This by applying these four figure, you able to understand what the statement of the Thevenin theorem is all about. So let's first of all, in as per the statement of the Thevenin theorem, if in the figure A is the required network or the said network, in which this two terminal is there, AB means this AB is the terminal where you have find out the current. So first of all, open the load resistance. In the first step, what you have to do, to open the load resistance, means you have to open AB. Now second step, after open this AB terminal, circuit become like this. See here, you have to find out the VTH over here. So how do you find out the VTH? So see, calculate or the measure the open circuit voltage. This is the Thevenin voltage by applying simple Ohms law, right? If the network is more complex, then apply the different tool like mesh tool, nodal analysis, like this. Now the third step is that open circuit source and open circuit source and the short voltage sources. And the fourth one, calculate the open circuit resistance by the Thevenin resistance. See, earlier you have seen that there is a voltage source or a current source might be in the network. Here the voltage source is there, while if the circuits having voltage source, the third step said that you must have, if the voltage source is connected, use short circuit as voltage sources. If in question, yeah, in problem, if the open circuit, if the current source is there, then open circuit this terminal. So here the voltage source is that, that's why I have short circuited this voltage source like this. In figure C there is no voltage sources there. And then find out the RTH. So simple by series parallel circuit is there, then you have to find out the RTH. After the step 5, once we have find two things, the VTH and the RTH. So what you have to do in the next step, you just connect like this. Whatever you find out in RTH, connect with this VTH, where in this step we have find the VTH. So connect the VTH, whatever voltage is coming obtained by calculating the VTH, and whatever the RTH is connected. So both are connected in series, and then connected the load. In first step we have removed here. So connect the source and calculate the total current of the circuit. So these are the 6 steps. Are applicable for finding the VTH, means Thevenin theorem. Let's take an example. Yeah, this is the practical example. In which we have find out the given problem by applying the Thevenin theorem. So while finding the VTH and RTH, this given network, what earlier I have said, and go and see the step by step to solve how to solve the Thevenin theorem. So this is the network. 48 volt is the source and the load is 5 kilo ohm. So you have to find the current over here. So this is the load resistance. See, as per rule or the step first, open the 5 kilo ohm resistance. This is the load resistance like this, and circuit become like this. See, open the load resistance. Now in next slide, step 2, we have find out the Thevenin voltage VTH across this. So calculate or measure the open circuit voltage. This is the Thevenin voltage according to the rules or the step of the finding the Thevenin theorem. We have already removed the load resistance in figure 1. So the circuit become an open circuit as shown in the figure 2. Now we have calculated the Thevenin voltage. Since 3 milliampere current flow into both 12 kilo ohm and the 4 kilo ohm resistance, as this is a series circuit, because current will not flow the 8 kilo ohm resistance as it open. See, once we have opened this terminal voltage, अगर हम इस voltage terminal voltage को open कर देंगे, means current will not flow in this branch. So 8 kilo ohm is worthless. So only the current is flowing in this loop. So by applying simple Ohm's law, you find out the current. So current is coming 3 milliampere, right? So only 12 volt. So only 3 total current is find out the 3 ampere, means 3 ampere current flow in this direction. So what is the voltage drop across 4 kilo ohm? 4 kilo ohm. Simple. V into I means 3 into 4 into 3 means 12 volt. Milliampere is there and kilovolt is there. So solve this, calculate this 3 into 3 milliampere and 4 kilo ohm. You have find out the 12 volt. So 12 ohm is the VTH, right? So 12 volt is the VTH. So in second step we have find out the total voltage, total VTH. Now in next slide, what you have to do, you short circuit the voltage source as per the rule. I have short circuited this terminal voltage and find out the RTH. by simple series parallel circuit. So these are the parallel circuit, and after getting the parallel circuit is connected with series 8 kilo ohm. Then you have to find out the 8 kilo ohm, 4 kilo ohm and 12 kilo ohm is a parallel with 8 kilo ohm the series circuit. Then you have to find RTH is 11 kilo ohm, right? Now in the next slide, step 5. Step 5, the 12 volt is the VTH. We have find out by using this in a step 2, and this is the step 4 in which we have find the RTH. Connect this in a series with the load RL and find out the total current. See, this is the final step. Now apply the last step in Ohm's law. Calculate total current and the load voltage across this one. So total current IL, if the load current is flowing here, IL is equal to total voltage VTH. VTH is this divided by RTH plus RL. RTH is 11 kilo ohm and the RL is 5 kilo ohm. So once we have find out this, IL is equal to 0.7 milliampere, and if we find out the this VL, the VL is equal to IL into RL, means whatever the voltage drop is occur on this resistance, this will be like this. So this is the simple way, or this is the step by which we have calculate, or this is the procedure to calculate the Thevenin theorem. Now in next slide, this is applicable for the DC circuit. While if the circuit is given AC, if the AC source is given to the circuit, then the steps are same, only we have calculated the different things. So let's go for the, so this is another example I have taken, but you have find out this solution. Go through the Google Classroom and find out the solution where I have taken some class work over there. So go through and download it and solve this problems. So I am going to be in the next slide the AC Thevenin theorem. AC Thevenin theorem is the equivalent circuit if the any linear network circuit is stated that two circuit given below the equivalency, the form that the load ZL is that the same of both cases. This is the ZTH, this is the ZL. VTH is equal to Thevenin voltage is equal to voltage across AB. This is the terminal voltage. Disconnected is equal to infinity. That open circuit voltage is VOC. So here we have said the VOC. Now the statement is similarly same, only the voltage source is changed. So ZTH is equal to Thevenin impedance, where we have said that the Thevenin earlier in DC circuit we have said the Thevenin resistance. Now is equal to here Thevenin impedance is equal to input impedance with the independent source turned off. Voltage source is replaced by the short circuit and the current source replaced by the open circuit. This is this is the impedance seen by the terminal AB when all the independent sources are turned off. Like the DC circuit, here we have used the term impedance. Now if we take one problem by showing this pictorial view, this is the circuit in which we have connected the connected the AC sources. So AC source is connected with this like this. Current source is there and the AC source is there, having some voltage with the magnitude. Only difference is that. So what you have to do, once we जहाँ पे हमें निकालना है, जिसके क्रॉस में निकालना है current, what we have to do, we have to do open circuit voltage, find out the open circuit voltage. So remove this terminal and find out the VOC, and after finding the VOC, find out the VTA, VTA, VTH, VOC. After find out the RTH, or the impedance RTH. Instead of RTH, the Thevenin resistance, we have find out the impedance and connect this impedance in the circuit in the next slide. Yeah. Yeah. Open circuit voltage. So the open circuit voltage, from this is the step 1, find out the VOC, find out the VOC by using simple this formula. It's the total voltage V plus the impedances to 1 minus J. This is the complex form. The complex form, we have to written VOC is equal to 8 minus J2. After that, you have to find out the ZTH. ZTH means find out the impedance. So impedance is written like this. This is all about these two capacitor and the resistor are in series. In the complex one, we have written 1 minus Ji, and this is the, and then circuit will become like this. Next slide. Yeah, this one. So we have find out the this current, load current. So load current, how do you find? This is the total VOC, and this is the ZTH impedance. Connected series, same as in DC circuit, and connect the load whatever you have omit in the first slide, on the first step, this one. So connect all this thing and calculate the total voltage of the load current of the find out the load current. So by using the simple V is I is equal to V upon R. So total V is 8 minus J2, and R means the impedance. So these two impedance and these two are in series. So so connect this in series and find out it I load. So I load become like this. This is the load current which have for the AC circuit. So this is the way in which we have find out the both the DC sources and the AC sources. If we apply the DC sources, then we have find out the RTH. If we connected the AC source, then we find out the impedance. So this is the main difference between while we are using the sources. So this is the all about the Thevenin theorem, in which we have studies the DC source as well as the AC source. So today I am stopped the lecture, and in next lecture we have seen the same both in the case of the Norton theorem and so on. Thank you.